Hi everyone, let's go through revision of entire limits and continuity chapter today. We will cover all of these topics given here at a high level with the key examples so that it will help you to quickly summarize the entire chapter before the exams. Also do watch out for revision playlist in my channel because I will be uploading revision videos of other chapters as well. The link to the revision playlist would be given in the description box. If you need detailing on any particular topic, do drop in your comments in the comment section. So today we will cover all of these topics related to substitution, factorization, rationalization, using theorem, trigonometric limits, applying limits on exponential logarithmic functions, limits at infinity, and continuity. So let's take the first method, which is direct substitution. This is simplest of all, where we just have to substitute the value of x given here in the function, right? So every time in any expression, we will have to apply direct substitution and see if it gives a valid value. So here, for example, you just substitute 1 here for x, and you're quickly going to get a into 1 plus b into 1 plus c by c into 1 plus b into 1 plus c. So we're going to get a plus b plus c by a plus b plus c. This is going to get cancelled, giving you 1. Let's take another example, right? Here, in this case, we can again do direct substitution. What do we get? We'll get minus 3 the whole square plus 9 by minus 3 plus 3. Now, what are we going to get? We are going to get 18 by 0. 18 by 0 is infinity. Getting 18 by 0 is valid. Getting 0 by 0 is not valid. So whenever we get 0 by 0, we will have to identify a different method of simplifying the function, then finding the limit. So let's take an example on factorization method. In factorization method, we will have to find out the factors. So whenever we have an expression like this, right, we will have to arrive at factors. Let's first let's apply the direct substitution method. Let's see if you are getting 0 by 0. If you are not getting 0 by 0, then substitute the value and get the limit. Let's see if you are going to get 0 by 0 here. So 2 into 4 minus 5 into 2 plus 2 by 2 square 3 into 2 plus 2. We are going to get 0 here. 4 minus 6 plus 2, 0. So this is indeterminate. So now we will have to simplify it. Now how are we going to simplify it? We are going to identify the factors for this expression. So we are going to get the factors for this one first and factors for this one. Then what will happen is one of the factors will get cancelled and then we can substitute. So let's first factorize it. One method to factorize is sum product. This is one method. What will happen is take sum product. So your product is, you'll have to multiply these two numbers. So you get 4 and you have sum is minus 5, the center one, right? This is minus 5. Now we will have to choose two numbers whose product will be 4. And when you add those two numbers, you'll get minus 5. So now in this case, we can take 4 and 1 as the number. If you multiply 4 and 1, you're going to get 4. And if you add 4 and 1, you're going to get 5. Right? You're going to get 5 here. Now you'll have to look at the signs. You have minus 5 here, which means one of the numbers should be minus, right? Or both the numbers should be minus here. If one of the numbers is minus, then we are going to get 3. So we'll make both as minus. So minus 4 minus 1 is going to be minus 5. And minus 4 into minus 1 is going to be plus 4. So both the sum condition and the product condition is satisfied. So we will get minus 4x and minus 1x. We will have to substitute this in place of minus 5x. So we will get 2x square minus 5x is minus 4x minus 1x plus 2. So we've written 5x as like this. We have split 5x into two terms like this. Now we will take the common between this and this. Common between this and this is 2x. So we'll get x minus 2. We'll take minus as common. So you'll get x minus 2. Why am I taking minus as common? So that I can make this factor also equivalent to this. This is x minus 2. I want to make this one also as x minus 2. So I take minus outside. So now I'll take x minus 2 as common between these two. So I'll be left with 2x minus 1. Now these are the factors for the numerator expression. Similarly, we'll have to do for denominator. For denominator, we'll get quickly x square minus 3x plus 2, right? So product and sum. Product will be, here you can use a simpler method. product is 2 and sum is minus 3, right? Sum is minus 3 and product is 2. So what will be the two numbers? It can be 2 and 1. If you multiply 2 and 1, you're going to get 2. If you're going to add 2 and 1, you're going to get 3. But we need minus 3 here. That means both of them should be minus, because minus 2 and minus 1 is minus 3. Minus 2 into minus 1 is plus 2. So numbers are, or the factors are, x minus 2 and x minus 1. These are the factors. So we'll put this. Here we don't have to split. For this expression, you don't have to split 3x like the way we did for earlier one. Whenever you have coefficient as just 1, we can directly take the numbers and get the factors. So it will be x minus 2 and x minus 1. So we have factors for denominator and we have factors for, this is for numerator. So let's substitute now. Limit x tending to 2. First one is 2x minus 1 into x minus 2. And the denominator what we got is x minus 2 into x minus 1. X minus 2 and x minus 2 gets cancelled. We are left with 2x minus 1 by x minus 1. Now we will do direct substitution. We'll get 3 by 1. Let's go with the method of rationalization. Whenever you have a fraction, an expression with a fraction, you will have to use rationalization. And also when you have square roots, in that case also we'll have to use rationalization. But before even we decide to go with rationalization, we will have to do substitution. So if you substitute here with x as 0, what we are going to get? We are going to get root 1 minus root 1 because x is 0 and 0. Now this is going to be 0 by 0. This is indeterminate. This is not acceptable. So now we will have to go with rationalization. So what do we do for rationalization? We multiply and divide the numerator and denominator by this expression, whatever is given here, but with an opposite sign. So let's copy this expression, limit x tending to 0. So we will multiply and divide the numerator and denominator by this expression, which is root 1 plus x plus root 1 minus x by same thing. So notice this. This is minus here and this is going to be plus. That's what we do in rationalization. Why we do this is because this will get simplified as we solve it further. So one key formula that we have to remember in rationalization is a square minus b square is equal to a plus b into a minus b. This is very, very important, right? Because in all the rationalization functions, we will have to use this. So if you look at this particular expression, this is a, this is b, root 1 plus x is a, root 1 minus x is b, isn't it? Right? If you look at this, this is of the form a minus b, and a plus b should give you a square minus b square, which means we will have to write this as root of 1 plus x the whole square minus root of 1 minus x the whole square by x into root of 1 plus x plus root of 1 minus x. And now square root and square will get cancelled. This is why we do rationalization, so that we can eliminate square root. We are going to get 1 plus x minus 1 minus x by x into root of 1 plus x plus root of 1 minus x. So here 1 and 1 is going to get cancelled. We are left with x minus of minus x, which is 2x. So we get 2x by the same denominator here, right? X into whatever. Now further solving this, we will get, so cancel x and x. So we will be left with 2 by root of 1 plus x plus 1 minus x. So now we can do direct substitution. So what, limit x tending to 0. So 1 plus 0 is 1 plus, so 2 by 2, which is 1. So answer is 1. I hope rationalization is clear. So whenever we have fraction in the expression, something like this, or whenever we have square roots, we will have to apply rationalization. And first we will have to do substitution and check if it is giving 0 by 0. If it is giving 0 by 0, then we proceed with rationalization. And this formula is very important whenever we rationalize. A square minus b square is equal to a plus b into a minus b. Now the third method, we'll go with the theorem. right? The usage of theorem. The theorem states that limit x tending to a, x to the power n minus a to the power n is equal to n into a to the power n minus 1. We will have to notice this form. This form is similar to this, but there is one problem here. X minus 2 is on the top and this expression is in the denominator. It is reverse basically. So what we can do, we will have to get this to this particular form. What we can do is, we need in the denominator, we need x minus 2, right? We need this. Then this is going to be similar to this form and we can apply this theorem. So, but if we divide denominator by this, we'll also have to divide numerator to balance the expression. So, we will do this. We will have to divide numerator and denominator by x minus 2. So, this is going to get cancelled and we are going to get 1 by, now this is of the form, this is of this form. So, what's the theorem? N into a to the power n minus 1. N is 1 by 3, a is 2, 1 by 3 minus 1. So, what is that? It's going to be 3 by 2 to the power minus 2 by 3. Here we have 2 to the power minus 2 by 3. If we can take it to the numerator, it's going to be plus. So, it's going to be 3 into 2 to the power 2 by 3. So, this is the answer. There are related sums. So, we have a sum like this. So, here also we'll have to apply the theorem. But only thing is, here the denominator should be x minus 2, right? So that you can apply the theorem. So, what we'll have to do is, we will have to divide the numerator by x minus 2. Divide the denominator also as x minus 2. Then we can use the theorem. In this case, if you take this particular sum, here you'll have to have a to the power, this is a, right? As per this theorem, we should have a to the power something. And what is that something? So we will have to figure out. So in denominator you have 2. So obviously this is going to be 2 to the power something. So this is a clue. When you have some number in the denominator, you can use the same number to get the power. So x cube minus 2 cube. So we are going to, now we can use the limits formula and then arrive at the limit. Let's take another example. This is little lengthy one. Let's try this out. Here what we'll have to do is, we'll have to obtain the factors, right? Once we obtain the factors, we will have to find the LCM or we'll have to cross multiply. And then do a substitution. So quickly we will get, first of all, the factors for this would be x minus 3 and x minus 1 are the factors. So 1 by x minus 3 minus 2 by x minus 3 by x minus 1. We'll take 1 by x minus 3 as common. So we'll get 1 minus 2 by x minus 1. Now we will cross multiply. So it's going to be x minus 1 minus 2 into 1. And this is going to be x minus 1. So we'll get x minus 1 minus 2 is going to be x minus 3 by x minus 1. And then we have this 1 by x minus 3. So now this will get cancelled. We'll be left with 1 by x minus 1. Now we can directly substitute x value, which is 3. 1 by 3 minus 1, which is half. This is the answer. Let's go through the fourth topic, which is trigonometric limits. So in trigonometric limits, there are a set of formulas that we have to remember along with two theorems here. Limit theta tending to 0, sine theta by theta is 1, tan theta by theta is also 1, right? And there are other formulas that we'll have to remember. 1 minus cos x is 2 sine square x by 2. We will substitute this and then we will get the limit. In this example, sine 4x by 2x. So now we want this particular form, theta by theta. That means we should have 4x in the denominator. We can multiply and divide numerator and denominator. So we will do limit x tending to 0, sine 4x by 4x. We'll multiply and divide. Similarly, we'll do sine 2x by 2x into 2x. We'll have to take this as a separate function and this as a separate function. Let's not club both. Let's apply limit separately for this, limit separately for this. So we'll apply theorem for this, theorem for this. So now we can apply, this is of this form, right? So sine 4x by 4x is 1. Sine 2x by 2x is also 1. So we'll get 1 into 4x by 1 into 2x. X and x will get cancelled. 2 1s are 2 2s are. So we'll get 2 as the answer. Let's take another key sum. 1 minus cos 2x by sine square 2x. Right? Here we'll simply have to remember this key formula. 1 minus cos 2x is 1 minus cos 2x is sine square x by 2. Remember this, it's x by 2. Let's not forget to substitute. Sine square 2x, sine 0 is going to be 0 and cos 0 is 1. So we are going to get 0 by 0 here. Cos 0 is 1 and sine 0 is 0. Substituting this formula, 1 minus cos 2x is 2 sine square x by 2. X is 2x here by 2. So we'll have to divide by 2. And then we will just copy this. Now we will proceed with sine square 2x. We'll get 2 sine square x by sine square 2x. We will have to get this to the theorem format. That is sine theta by theta. How can we do that? So you have here sine square x. We need x in the denominator. And we need only one sine x. But there is sine square x. So we can split this into sine x into sine x. So we can write this as 2 sine x into sine x by sine 2x into sine 2x. And then we multiply and divide each of these terms by x into x by x. That is 2 sine x by x into x. And then we take another one, sine x by x into x. Same thing we'll do with denominator also. Sine, here we need 2x in the denominator. This is of this theorem format. Right? So we will substitute the theorem. We'll get 2 into sine x by x is 1 into x. Again this limit sine theta by theta is 1. So we'll get into 1 into x. Same thing down. We are going to get 1 into 2x. 1 into 2x. Right? X, 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 all this will get cancelled. 1, 2 will also get cancelled. We'll be left with half as the answer. There's another example here. Sine ax plus bx by ax plus sine bx. Here also we'll have to do the same thing. We'll have to multiply and divide ax by ax and bx by bx. So that you can apply the sine theta by theta formula. And then one of these terms will get cancelled. Ax and bx will get cancelled and you will be getting the limit. There are also related sums. Here also the same thing we'll have to do. If you get sine 2x plus sine 6x, you multiply and divide. So in this case, what you can do, sine 2x into 2x by 2x plus sine 6x into 6x by 6x. Then here sine 5x into 5x by 5x minus sine 3x into 3x by 3x. So apply the limits for this much. Right? And then x and x will get cancelled and then we'll evaluate. Here also same thing. Sine ax into ax by ax plus bx. Ax plus sine bx into bx by bx. So here we can apply the theorem. So it will be ax is going to be 1, left with ax plus bx by ax plus bx. Both of this will get cancelled and the answer will be 1. There is another type of trigonometric expression here. Here you have 1 plus sin x and basically this is a rational function. In this case what we'll have to do is we'll have to rationalize it, multiply and divide by this numerator expression, put a plus sign and then evaluate it the way we did it earlier, right? For a polynomial function. Similarly we'll have to do this for trigonometric function. And remember this value, sin 0 is 0, cos 0 is 1. We will have to use these values in this expression. We'll have to rationalize. We'll have to multiply and divide by the numerator expression with the opposite sign, right? Here we have minus, so here we're going to have plus 1 minus sin x by, now we'll have to put that a plus b into a minus b is equal to a square minus b square, right? This is of the form a minus b and a plus b, where a is root of 1 plus sin x, b is root of 1 minus sin x. So we are going to get 1 plus sin x the whole square minus 1 minus sin x the whole square by the whole denominator. Now what's going to happen here? This root and square is going to get cancelled, and 1 and 1 is also going to get cancelled. We are going to left with sin x minus sin x minus of minus sin x. So it's going to be 2 sin x and x into this entire root, right? Now if you observe, this is of the form sin x by sin x, right? We can apply the theorem here, which will be 1. Then we are going to get 1 here, and we'll substitute the values of sin x here. So we'll get 1 plus sin 0, which is 0, and 1 minus sin 0, which is again 0. So we'll get 2 by 2, which is 1. This is the answer. One more thing I wanted to reiterate, right? There are related sums related to 1 minus cos 2x. There are related sums. So 1 minus cos x by x is one sum. Same approach. Substitute 1 minus cos x as 2 sin square x by 2. You should make it x by 2. Don't forget that. Similarly, if you have 1 minus cos 4 theta, this is going to be 2 sin square 4 theta by 2, right? So you have to put 4 theta by 2. Here you'll have to put 6 theta by 2. Similarly, there is another sum here. Same thing. Everywhere it's the same approach. Put this particular formula and then put this by 2, right? For whatever theta you have here or whatever x you have, you should put by 2. So if you have 2x, it's 2x by 2. If you have 4x, it's 4x by 2. 6x, 6x by 2. So next subtopic is on applying limits to functions of these form, right? There are exponential functions, there are logarithmic functions, there are functions with fractions. So all of these formulas we will have to by heart, and we'll have to check if these form exists in the question or in the expression. Let's take this first example. We have 1 plus 2 by n to the power n. Now if you see this is of the form 1 plus 1 by n to the power of n, right? And 1 plus 1 by n to the power n is e, right? But here we have 2 by n. What we have to do? We have to eliminate this 2. How we can eliminate? Divide it by 2. Simple. So divide the numerator also by 2, denominator also by 2. So you will get 1 plus 2 by 2 by n by 2, because both numerator and denominator we have to divide, right? So now to the whole power n. So this is going to get cut, and we are going to left with 1 plus 1 by n by 2. This is how we are going to have. But again, this is still not of this form, because here we have n by 2 and here we have n, which means here also we should have n by 2. Only then we can apply this. To put a 2 here, again we'll have to multiply and divide the power also by 2. So this is going to become like this: 1 plus 1 by n by 2. We can write this as n by 2 into 2, or we can put this like this: n by 2 into 2. So now if you see, this is of that form, right? 1 plus n by 2 to the power n by 2, which is e. So this is going to be e, and then we have square here. It's going to be e square. So remember one thing again to summarize: if you have number as 2 here, we'll have to eliminate 2. Best way to eliminate 2 is to divide numerator and denominator by 2, and then we need to get power also same as the denominator. So see here, the power is n, denominator is n, and it's n tending to infinity. So all of this should match. So that's why we multiply and divide by 2. Let's take another example. If you notice, this is of the form 1 plus x to the power 1 by x. And what is 1 plus x to the power 1 by x? It is again e. Limit x tends to 0. 1 plus x to the power 1 by x is e, right? But here we have 3x, right? This and this is not matching, right? We need to have x here and x here. But here we have 3. So what we are going to do? We are going to bring in 3 here also. How do we bring in 3 here? Again the same approach, multiply and divide by 3. So we will do this: 1 plus 3x, 1 by x into 3 by 3. So what's going to happen? We're going to get 1 by x, then we are going to be left with 3. So we'll do this. The whole 3. We take this 3 outside, and then put 1 by 3x inside, right? Now this whole thing we can apply a theorem, right? So this is going to be, this whole thing is going to be e, and then we have 3 here, e cube. So this is important because in continuity we see this expression used a lot, where we have e as an value and then we get this power. So remember this, folks. This is another important one because we have seen this in continuity. Without this we will not be able to solve the continuity problem. So we'll have to for sure remember this formula and the one that I mentioned earlier, right? This is frequently used. Try to memorize this. So here, look at this form. It's similar to this, right? Only thing is here instead of x we have minus 3x, right? So what we can do, we'll have to make the denominator also same as this, because here if you have x, the denominator also should have x, but here we have minus 3x, so the denominator also we should have minus 3x. So we multiply and divide the denominator by minus 3. So this is what is going to happen. E to the power of minus 3x minus 1 by minus 3 into x by minus 3. We're going to multiply and divide by this. So we're going to get e to the power of minus 3x minus 1 by minus 3x. This minus 3 is going to go on top. So if you see, this is of this form. Then we can apply the limits value. So it's 1 year. So we're going to get 1 year into minus 3. The answer is minus 3. So let's take another example here. 2x to the power x minus 1 by 3x. This is exactly same as the earlier one where we had e to the power x minus 1 by x. Here it is a to the power x. So when you have e to the power x, the value is 1. When you have a to the power x, it is log a to the base e. Remember this pattern, huh? This pattern has e to the power x. This is the same thing but with a to the power x. Here the answer is 1. So when you have e to the power x, answer is 1. When you have a to the power x, it's log a to the base e, right? Now a is 2 here and we have x. So we can directly do the substitution. So this is of this form, right? So we'll get log e, a is 2, and we have 3 here, 1 by 3. So this is the answer. Let's go with another topic, which is limits at infinity. So basically these are functions where limit tends to infinity. Limit x tends to infinity. So this is the only indicator where we know we have to apply this method. So whenever we have something tending to infinity, then we will have to apply a method here. So what is the method that we have to apply? So here we don't need to get factors. We have to get factors when we have x tending to some value, right? Say 0 or 2 or whatever. But when we have x tending to infinity, here we have to modify the approach. What is it we are going to do here? We are going to take x square as common, right? The highest degree. Which is the highest degree here? X square. And here also it's going to be x square. We'll take x square as common, or we'll divide this entire numerator by x square. What's going to happen? If you divide this entire numerator by x square, similarly denominator also will divide by x square. We'll divide and we will get 3 here. We'll get minus 4 by x plus 5 by x square. This is the numerator. For denominator we'll get 2 plus 5 by x minus 1 by x square. Now we'll put the limit. We'll substitute the limit value. It is x value. What is x? X tends to infinity. We'll substitute 3 minus 4 by infinity, 5 by infinity. Why we do this? Because anything by infinity is 0. 1 by infinity is 0, right? So we will put 0 here. So it will simplify. So what we will get? We will get 3 minus plus 0 minus 0. So we are going to get 3 by 2 as the answer. So now we are able to correlate. Whenever we have x tends to infinity, right, we'll take the expression and divide with the highest degree. So if you have x square here, we'll divide by x square, both numerator and denominator. Suppose we had x to the power 3 here, we will divide by x to the power 3. X to the power 8, we'll divide by x to the power 8. Basically, so that we will get this form. When we get this 1 by x form, right, we will substitute x as infinity, and anything by infinity becomes 0. So our equation gets very simple. Everything will become 0 and we'll get the limit value. So remember this. Whenever there's an infinity, the approach is slightly simpler. Don't get confused with factorization here. Here we don't have to apply factorization because it's infinity. We will take another easier approach here. Let's go through the last topic, which is continuity. And this is a key topic. We'll get it for 3 marks. So let's focus on all the problems of continuity. I've tried to cover all the types of the problems so that we're thorough with this. And one thing with continuity is we have to follow the exact steps of the exact theory. Right? Let's take the first example. Show f of x is continuous when x is equal to 5. So we'll have to first take the limit on the expression which is not equal to 5, which is less than 5 or greater than 5 but not equal to 5. So this is the expression, right, which is not equal to 5. On this we'll have to apply limit. Why we'll have to apply limit? Because limit is always applied on a value which is very close to the actual value, right? If x is equal to 5, we will apply limit on the expression when x is very close to 5, say 4.9, 4.99, 4.9999, but it will not be 5. We'll take the first expression, apply the limit f of x tends to 5. We'll take this expression. If you notice, this is of the form x to the power n minus a to the power n by x minus a. So we'll apply the limits theorem and we will get 10, right? We'll call this as expression 1 or equation 1, right? Then we will take the second expression when x is equal to 5. So we'll tell f of 5, because when x is 5, which means f of x, which is f of 5, is 10. It's already told that f of 5 is 10. So we'll just put f of 5 is 10 when x is 5. Now from 1 and 2, the values are same, right? Here also the limit value is 10 and f of 5 is also 10. So from 1 and 2, limit x tends to 5, f of x is equal to f of 5, which is equal to 10. Therefore, we call this function as continuous at x is equal to 5. So these last 4 lines are very, very important, right? The entire marks is dependent on all this theory that you write. From 1 and 2, limit x tending to 5, f of x is equal to f of 5, hence f of x is continuous. So basically the values that we get when we apply limit on the expression should be same as the value at x is equal to 5. So this value and this value has to be same. Only then we say that the function is continuous. This is a question where they say the function is already continuous at x is equal to 0, but we will have to find the limit actually. That's all. So what we will do, we have square root here, right? And this is a rational function. So we will simply rationalize. The moment we see a square root and there is a rational function, we will rationalize it. We'll take the opposite sign, multiply and divide the numerator and denominator by this particular expression with the opposite sign. So once we rationalize, we are going to get the limit value as 2, right? Now, this is when f of x is 0. So we substitute x is 0 and we get the limit value as 2. So f of x is 2. This is the answer. So let's take another example where we have to show that f of x is continuous at x is equal to 0. What we have to do? We'll have to first take the expression which is not equal to 0, right? Not the one which is x is equal to 0. We'll have to take the expression which is not equal to 0. This one, first one. And we apply a limit on that. So limit x tends to 0 because it's continuous at x is equal to 0. We make it as limit x tends to 0. F of x is equal to limit of 1 plus 3x. This entire expression we copy. Then we'll have to identify the form here, right? It is of the form limit 1 plus x to the power 1 by x, which is equal to e, right? This identifying this form is very important. So memorize this formula as many times as you can. These are all key questions, right? Probability of getting them in the question paper is more because in the previous question papers seen that this has occurred multiple times, these kind of questions, right, where we have to prove that it is continuous. So now the formula is 1 plus x to the power 1 by x, but here we have 3x, right? If here we have 3x, then we have to ensure that the power is also having 3x, right? So what we do, we multiply and divide by 3, right? And then we'll get it like this. We split it 1 by 3x and the 3 will put it outside just to be clear, right? To make it clear. So this portion is of this form now, this form. So the limit value for this is e, and we already have 3 here, so it's e cube. Then we'll tell f of 0 is equal to e cube, because they've already told that x is equal to 0. At x is equal to 0, f of x is e cube. So f of 0 is e cube. Now if you see this 1 and 2, both are same. The values are same. Since it is same, we call that f of x is continuous. So we'll have to write this theory, very, very important. From 1 and 2, limit x tending to 0 f of x is equal to f of 0 is equal to e cube. Hence, f of x is continuous at x is equal to 0. So let's take another example where we have to, it is already told that function is continuous at x is equal to 0. We'll have to find this value. So let's take limit and apply on this expression where x is not equal to 0. So let's apply the limit here. Now this is of the form 1 plus x to the power 1 by x, and it is e. So, but here we have 2x. We just need 2x here in the power. So same case, we multiply and divide by 2. So we'll get this form, right? And then we'll put here, we'll substitute e here, and then we have 2 here, so e square. So we got the limit value for the first expression, which is e square. Second expression is k. So second expression f of 0 is k. They've already told. We'll have to find this value. They have told that it is continuous already. If it is continuous, it means f of x, this f of x is equal to f of 0, since it is continuous. Both these expressions should give the same limit value. That is, what limit value you get when you evaluate this, and this should be same. That is why they are telling it as continuous. So we'll have to equate equation 1 to equation 2. So we'll have to write this theory again. Since f of x is continuous at x is equal to 0, limit x tending to 0 f of x, that is the first expression, is equal to f of 0, which is the second expression, and this is k. So the first expression is what we got, e square, and we should equate it to k. That means k is e square. So this is the answer. So again, to summarize, whenever you have to find k and they've already told it is continuous, you have to find the limit value of the first expression, the expression which is not equal to 0 or less than 0 or greater than 0, apply limit on that, get the value, take the second expression, which is x is equal to 0, equate both of these values, and then you'll get value for k. But this theory, you have to write it in this particular sequence. Let's take another example. Here we'll have to discuss the continuity, which means we will have to tell if these functions are continuous or not. So you have an expression when x is less than 1, when x is equal to 1, and when x is greater than 1. We will have to show if it is continuous or not. We don't know if it is continuous or not. We'll have to identify it. Now this, again, it's very important to follow these steps. We'll have to find the left hand limit. When you say left hand limit, that means in the number line, this is at x is equal to 1. So say this is 1. Any values before 1 is left hand side values, right? Any values greater than 1 is called as right hand values, right, in the number line. So anything on the left hand side will be less than 1 here. That means it will be 1 minus something. It could be 0.99, 0.999, 0.9999, like that, right? So we'll make it as, instead of specifying each of the values, we'll generically put 1 minus something, right? So we'll put limit x tending to 1 minus f of x. Now, what is f of x here? When x is less than 1. When x is less than 1, f of x is 3x square plus 1. So we put 3x square plus 1 here. And then we substitute x as 1 and get the limit value. So this is the left hand limit value. Now we'll come to right hand limit. What does right hand limit say? When it is greater than 1. Greater than 1 is right hand limit. So we'll put 1 plus. This is how we denote it. We need to put 1 plus f of x, limit x tending to 1 plus. What is the function when x is greater than 1? It is this one. We put this function here, evaluate the limit, and get the value. Now if you look at it, left hand limit and the right hand limit is same. Now we will also check at x is equal to 1. We saw limit at x less than 1, x greater than 1. Now we will have to check x is equal to 1. X is equal to 1, they've already given it as 4. That is, f of 1 is 4. That is, f of 1 is nothing but x is equal to 1, right? At x is equal to 1, f of 1 is 4. Now this we call as third statement. Now from 1, 2 and 3, LHL, RHL and f of 1 all are same. Therefore, f of x is continuous at x is equal to 1. Even if one of them is not matching, right? Even if one of the values are not matching, then we call it as discontinuous. Let's take another example where we have to show that the function is discontinuous. So here again we'll apply limit on the first expression where x is not equal to 3. If you notice, this is of the form x to the power n minus a to the power n. So we write 9 as 3 square and we put the theorem. So we get 2 into 3 to the power 2 minus 1, which is 6. Now this is the limit value for f of x when x is not equal to 3. And f of 3, that is when x is equal to 3, f of x is already given as 4. So we call this as equation 2. Now for 1 and 2, both are not equal, right? Limit x tending to 3, f of x is not equal to f of 3. Hence, f of x is discontinuous at x is equal to 3. So this theory we will have to write. Basically, because these two values don't match, we call them as discontinuous at x is equal to 3.